Hey guys, I'm Xandria.
And I'm Tate.
And today we're going to talk about a branch of pharmacology known as pharmacokinetics, otherwise known as PK.
What is pharmacokinetics?
Well, I'm glad you asked. Pharmacokinetics is the way that drugs such as pharmaceuticals, pesticides, cosmetics, and food additives move through the body in terms of absorption, metabolism, distribution, and excretion.
Hey, isn't that ADME?
Why, yes it is. A is for absorption, which is the way your body takes in the drug.
D is for distribution, which is the way the drug is distributed throughout the body.
M is for metabolism, which is the way that your body processes the drug.
And E is for excretion, which is the way the drug leaves the body. In order to talk about absorption, we first need to understand the way a drug travels through the body via the blood. So, a drug could start in the gut, and then it could go to the liver via the hepatic portal pathway, and then it could go to the vein, and then to the heart, the lungs, then back to the heart, and then it can circle back to the arteries.
This is a time-consuming process, which means depending on where in this process you administer the drug, it'll have different effects on the intensity and the duration that the drug is in your body.
There are several methods of intake for a drug. One common way is orally. This is commonly in pill form, and you take it orally and it enters the gut, and then it can follow through this pathway. Another common way is intravenously. If you take something intravenously, then it'll go straight into the veins, which enters quickly and more further down this pathway, and then it can continue down the pathway. And another common way is inhalation. If you take something through inhalation, then it enters the lung, which is way further down the pathway, and then it just continues on the rest of the pathway.
Here we have a graph that illustrates that information. So when a drug is taken earlier in the process, such as orally, we see it has a much lower maximum concentration, as well it reaches that concentration later on. And then when it's taken through inhalation, we see a very high maximum concentration, and it reaches that very quickly.
This information can be useful when determining what method to use for a particular drug. For example, some drugs are toxic and can't be at concentrations that are too high, so you might want to take those orally.
When talking about distribution, there are four major compartments we need to keep in mind. Those are plasma, fat, extracellular fluids, and intercellular fluid. When the drug enters the body, it is shared between these four compartments, and so then when a doctor assigns a dosage, he needs to keep in mind the equilibrium constants between these compartments, and in order for him to create the correct dosage for the correct concentration of drug.
Equilibrium constant can usually be abbreviated as Kc, and it usually depends on the permeability of the barriers between the compartments, the binding capacity of the drug, as well as the pH level of the different compartments. Next in ADME is metabolism. When talking about metabolism, we're talking about how the body processes the drug. So most drugs are processed in the liver, and this is done by enzymes. It's important to remember that enzymes are specific, so different enzymes process different drugs, and they do that differently. One other thing that is important to consider about metabolism is that, go back and think about absorption and all of our different methods of intake. If you don't want something to be metabolized quickly, then you might want to take it orally.
And then the final part of pharmacokinetics is excretion. And excretion is actually removing the drug entirely from the system. And that's done through two pathways, either through the liver and the kidney. And the liver will absorb the drugs, filter it into the bile, and then it will be removed from your body through feces. And then the kidney will also absorb the drug and remove it through urine.
The excretion of a drug from the body follows two different orders of kinetics. If a drug can be excreted right away, then it follows first order kinetics. In this case, the half-life stays constant. If a drug isn't excreted right away, then it follows zero order kinetics. This is usually due to limited enzyme activity, and it follows a linear fashion. It's easy to overdose on zero order kinetic drugs because the drug will only be excreted at a certain fixed rate.
This has been a brief overview of pharmacokinetics. Thanks for watching.
See ya.